In this video, we want to solve for a given 4 raised to power a times 4 raised to power a is equal to 400. This is an exponential problem. Since we have the same thing being multiplied by itself, we are going to apply indices. By indices, given a raised to power m times a raised to power n, if the bases are the same, irrespective of whatever the power is, we'll just pick one of the bases and then add the power, m plus n. That is one way to look at it. But what of when the powers are the same? We have a similar law of indices for when the powers are the same. Let's say, for instance, you have a raised to power m and then b, a different base, raised to power m still. What we do, irrespective of whatever the bases are, even if the bases are the same, what we do is say a times b and then pick one of the powers like that. So if we do that for this equation, we can use either of the two theorems. In this case, we are going to have 4 raised to power a plus a using this first approach, which is going to give us 4 raised to power 2a. So we can now say that 4 raised to power 2a is equal to 400. This is an exponential problem. To proceed from here also, we have so many other approaches. You can decide to break down this 400. If I break down 400, I'm going to get 400 is equal to 4 times 100, which can also be expressed as 2 raised to power 2, or 400 itself is 20 squared. We can also say 400 is 20 raised to power 2, and 20 itself is 4 times 5. Like I said, there are so many approaches to tackle this problem. So what it's going to mean from here is that 4 raised to power 2a is equals to 4 times 5 raised to power 2. So I'll say 4 raised to power 2a is equal to 4 times 5 raised to power 2. From here, I can take the logarithm of both sides. This is going to give me log 4 raised to power 2a is equal to log 4.5, 4 times 5 rather, raised to power 2. Let us apply another law of logarithm because of these powers. Given log m raised to power n, by logarithm you can express this as n log m. Doing that will take these powers behind the logarithm, giving you 2a log 4 is equal to 2 log 4 times 5. Let us divide both sides by 2 log 4. These two will take care of this, these two will take care of this, and log 4 will take care of log 4, and we'll be left with a is equal to log 4 times 5 divided by log 4. Now we need to separate this product using another law of logarithm. Given log m times n by logarithm, this is log m plus log n. Therefore, a becomes log 4 plus log 5 divided by log 4, which would then give us a is equal to log 4 divided by log 4 plus log 5 divided by log 4, and log 4 divided by log 4 here will give us 1. So we have a is equal to 1 plus log 5 over log 4. There's one more thing we can do to this expression. We can also express log 4 as log 2 raised to power 2. So we now have a is equal to 1 plus log 5 divided by 2 log 2. If I rewrite that, a is equal to 1 plus 1 over 2 log 5 divided by log 2. And then we can now apply this law of logarithm. Log m divided by log n is equal to log m base n. And finally, our a is now equal to 1 plus, this will now be 1 over 2. Applying this law, this will now be log 5 base 2, giving us the final answer for a. Let us now do a very quick check to confirm that this solution is correct. Recall that the equation given was 4 raised to power a times 4 raised to power a is equal to 400. And we have reduced this to 4 raised to power 2a is equal to 400. I will now substitute this value in place of a. This implies 4 raised to power 2 into 1 plus 1 over 2 log 5 base 2 is equal to 400. Let us open this bracket. This will be 4 raised to power 2 times 1 is 2. 2 times 1 over 2 log 5 base 2 will give us, this 2 cancels this, so we just have log 5 base 2 equal to 400. We can separate this power using law of indices. Given x raised to power m plus n, this will give us x raised to power m times x raised to power n. So this gives us 4 raised to power 2 times 4 raised to power log 5 base 2, which should give us 400. 4 raised to power 2 is 16. Here we need to reduce this to 2 raised to power 2 then times log 5 base 2 is equals to 400. Then we return this power all the way here, so that we now have 16 times 2 raised to power log. This will now be 5 raised to power 2 base 2 is equals to 400. This will give us 16 times 2 raised to power log 25 base 2 is equals to 400. By law of logarithm, x raised to power log m base x will give us 25. Will give us m rather. So here this is m. What I mean is this expression now will give us 25. Therefore, we have 16 times 25, which should give us 400. 16 here is 4 times 4, so times 25 is equals to 400. Now 4 times 25 is 100. Now times 4 should give us 400. And of course, 4 times 100 is 400, which means that the left hand side is equals to the right hand side, and that confirms that our solution is perfectly correct. Thanks for watching. Please like and share and subscribe to my channel. Bye.